right, turn your textbooks to page 433. 433 in your textbooks. And take your homework out as well. Unit numbers 1 through 4, 6, 8, 10, and 12.
I grabbed the wrong book. I tried.
All right. Do have a test coming up Friday, and today is kind of our, not our last opportunity, but moving toward our last opportunity to make sure we understand how to add fractions, the complete process, figuring out your common denominator, rewriting the fractions so they have that denominator. In fact, let me drag this over just a little bit here and include that poster in the screen there. Number one, what was your common denominator? Maddie? 12. So I would start with the long line and put a 12 down below it. Now looking at the first fraction, it already has a 12. So do I need to change anything about the numerator class? No, leave that x plus 2. Looking at the second fraction, its denominator was a 3. I am changing it to a 12. And to change a 3 to a 12 class, you multiply by 4. And what you do to the bottom, do to the top. So when I multiply the top by 4, Gavin, I got
4x negative 12.
my last fraction has a denominator of 4. I have turned it into a 12 by multiplying it class by 3. Therefore, the numerator must also be multiplied by 3 to get positive 9x. From here, we just need to combine like terms. I got an x, a 4x, and a 9x to get 14x. I've got a 2 and a negative 12 to get all over, just negative 10, all over 12, but I'm not done because I can reduce. How can I reduce this, Brecken? Good, I can factor out a 2, leaving me with
7x negative 5.
and then the 2 and 12 can cancel to give me, so my final answer ought to be 7x negative 5 over 6. How many had this answer for number 1? How many left 14x negative 10 over 12 and just forgot to reduce? All right, Maddie, Brecken, questions? All right, looking at number 2. Only 2 fractions this time. Common denominator is, Gavin? 12. Neither one is 12 to start out with, so both numerators have to change. First fraction, top and bottom, would have to be multiplied class by 2 to get what new numerator here on number 2, Noah?
6a squared negative 4.
And the second fraction, top and bottom, had to be multiplied class by 3 to get what, Brecken?
3a squared positive 9a positive 12.
All right, then from here again, we combine like terms. We got a 6a squared, 3a squared class, 9a squared class. Got this 9a all by itself, of course, but then the negative 4 and the 12? Positive 8. Okay, so this time there isn't anything common, and I don't think I could find a good way to factor that up. Even if I did, even if I got factors, would either factor be able to cancel with a 12? No, a common factor might, but there isn't a common factor, so we'll leave our answer just like this. How many had 9a squared positive 9a positive 8 over 12? Questions on this one? Number 3. What was your common denominator you put under the not so big long line? Maddie? 2x. Now the second fraction already had 2x, so I don't change anything about its numerator, it just stays a 3. But the first fraction only had an x, which means the first fraction had to be multiplied top and bottom, Noah, by
2
to get,
10x.
well, just 10. We already had the x, right? It was 5 over x, so all I had to do was multiply by 2 to get 10. I can combine the 10 and 3, of course, to get class 13 over 2x, and nothing simplifies there. We'll leave it like that. How many have this for number 3? Questions? Do we make the mistake of putting an extra x in for some reason?
I just got to add.
Just forgot to add them to get 13. Okay, don't forget to combine like terms. Simplify, even though it doesn't reduce, we still did simplification. Looking at the next one, number 4, Brecken, what's the common denominator supposed to be here? X squared, because of the contest, x squared is the winner. Once again, the second numerator, nothing needs to change because the second denominator didn't change. I just leave it as a But the first fraction, top and bottom, would have to be multiplied by to get. And I can't combine, I can't factor, I can't cancel. So 5x plus 3 over x squared, how many get this for number 4? Very similar problems in 3 and 4 questions. All right, dropping down to number 6 now. What was the common denominator here, Maddie? Good, 3 and a 4 represent by a 12. The A's are tied, pick one as the winner, and then the B is a winner by forfeit. So 12AB, how many have the correct denominator on number 6? All right, what needs to change in the first fraction? What needs to be multiplied top and bottom in that first fraction, Maddie? 4. I already have the 3AB times 4 would give me what for my numerator? And then for my second fraction, I had a 4A, meaning I would have needed to multiply what here, Gavin?
3b.
3B. To get what?
6ab negative 3ab squared.
From here, we need to try to combine some like terms. There are only 2 that combine, the 4AB and the 6AB class, to get 10AB. We do have that 4B at the end, and I'll put my, I don't really like a first term negative. We'll put our negative 3AB squared at the end still, all over 12AB. We should look to factor. And on the surface, it doesn't look like we can factor much, but there is something, class.
b.
A B can factor out, leaving me with a 10A, positive 4, negative 3AB, and then the B cancels with the other B. So we should specify that B cannot equal, class, 0, since it canceled away. So there's my answer, 10A, positive 4, negative 3AB, all over 12A, where B cannot equal 0. Again, the order of these terms, really largely up to you. There's not really a descending order per se, though technically the negative 3AB could be first. I just don't want a first term negative. I'm gonna flip-flop. Now, there is one little shortcut. Look at number 6, the first fraction in the book. If you had factored out the B in the top, and then canceled that B away, your denominators would have been 3A and 4A. And your common denominator would have been 12A, which would have been a little bit easier. Not a whole lot, right? But you still end up doing a factor and cancel, but it would have saved you the step at the end. I don't know that it saves you that much time one way or the other, so I'm not going to sweat it too bad, but just pointing out you could have perhaps done that. Number 8, what was your common denominator, Brecken? Or what should your common denominator have been, I should say?
18.
Okay, that's the number, and then any letters? Okay, because there's a 3-way tie with that x, isn't there? So 18x, our common denominator, that's what goes below the big long line. First fraction, Brecken, has a 3x. We wanted 18x. That means we have to multiply top and bottom by?
6.
Good. And when I multiply the top by 6, we get?
22.
The next fraction had a 9x. I need to multiply top and bottom, Noah, by? Stay with me, stay focused. We're looking at number 8 in your textbook. We want an 18x. My second numerator has a 9x, or second denominator is a 9x. Need to multiply top and bottom by?
2.
To get?
4. Negative 2.
Good. Then the final fraction had a 6x in the denominator, 1 and 18x. Need to multiply top and bottom, Maddie, by? To get? When we combine like terms, the 3x squared fortunately is positive, because I'd like to put that first, right? That's my leading power, and because it's positive, I don't mind putting it first. You combine the 6x and 4x, class.
10.
And finally, I've got the 24, negative 2, and positive 9 to get.
31.
Positive 31. It sure doesn't look to me like anything's going to factor here. And even if it did, because we have a monomial at the bottom, we'd have to have a common monomial factor. There is nothing like that. We'll leave this as our answer, 3x squared. Where do we go? Positive 10x, positive 31. Yes, over 18x is our answer. How many have that answer for number 8? Questions? Number 10 should have had a common denominator. Pretty straightforward here. Remember, I'm going to go ahead and show this step here. So as we get into the polynomials here, anytime you have a polynomial denominator, class, we need to do one of two things. Either factor or group it. And in this case, of course, it's going to be group it. So what's the common denominator here, Gavin?
3 times 1x negative 3.
Right, 3 times x negative 3. This 3 is not included as a part of this. It's a separate, distinct factor. Both of them need representation. So here, I'm going to have to multiply top and bottom class by the 3. And here, I'm going to need to multiply top and bottom by x negative 3. What do I write above the big long line, Gavin?
3x positive 3 positive x negative 3.
Hopefully you saw the 3 and negative 3 would cancel. I can combine the 3x and the x class to get 4x over 3 times x negative 3. I can't factor, so I can't cancel. So there's my answer. How many had that? 4, number 10. All right, any questions on that one? The number 12, what's the common denominator going to be here, Brecken? There we go. Both of these denominators, the x positive 3 and the x positive 2, need representation. Obviously, the first fraction, Brecken, we're going to need to multiply top and bottom by. What do we get above the big long line when we FOIL these, Maddie? Good, and then here, we multiply top and bottom, Brecken, by,
x positive.
and what do we get when we FOIL there, Noah?
X squared, negative 2x, negative 15.
When we combine like terms, of course, we have the x squared class,
2x squared.
we have the x and the negative 2x,
Negative x.
and we've got the negative 2 and the negative 15.
Negative 17.
You're not going to be able to factor that up, right? A 17 is only 1 in 17, so even with the help of a 2, you're not getting 1 for your middle value. It doesn't factor, so I don't have to worry about trying to cancel. There's my answer. How many had this? 4, number 12. How many had this? 4, number 12. Questions? All right. Keep your books out. We're going to get right back to them, but I got 2 problems I want you to work on your own paper for now that I'm going to put on the chalkboard before we get back to your books. So as if you wanted to put a marker in your book and set it aside or set it on the floor beside you laying open so it stays open to the page, that would be fine. But 2 problems for you to work there at your seats. We have an x negative 4 over 9 minus 2 negative 3x over 4 minus 2x positive 1 over 12. Remember, where it says minus, I know I need to remember to switch the signs, add the inverse, right? So keep that in mind as you work that one. And then I've got an a negative b over ab plus b negative c over bc. I'm going to work these 2 problems there at your seats. Do we get 36 for our common denominator? Raise your hand if you had 36 on the first one. Excellent. Now, look up here. One way to do this is to start by adding the inverse and then distribute the 9. That's one way to do it. Another alternative is when you distribute your 9, treat it like a negative 9. Does that make sense? Either way, check your answer so far, check your work so far. So we got negative 18, positive 27x. Did you get that? So over here, I need to multiply by a 3, but let's treat it like a negative 3. That changes the signs as I do it. Or, change the signs first, then distribute the 3 to get negative 6x, negative 3. Are we good so far on this problem? All right, keep working. Finish with both? Excellent. Check your answer on the first one. Did you get 25x negative 37 over 36? Getting a nod? Good. Kevin checking. If you're good, continue working on the second problem. You got that as well, Brecken? Okay, excellent. What about for our second problem? What's the LCD?
ABC.
ABC. How many get ABC for this denominator? Maddie just starting? Brecken? Just starting. Okay, does ABC make sense? Is that what you would have gone with? Okay. Any questions on the first one, or shall I erase? Anyone need it left up? You could go one of two ways with the answer on this one. Either answer is correct. Did you get one of those answers? You did not. Okay, did you cancel away the ACs?
I forgot to bring out the B.
Okay, so you left it as either this or that with the negative up front. Okay, yeah, so factor the B and then cancel the B. We don't need to say B can't be 0 because what B? But the book for it would argue you need to specify book B can't be 0. So did you get one of those answers? You did. You did. And then Brecken finishing up. While he's finishing, page 433. 19 and 24. Page 433, 19 and 24. Okay, careful. You're right, you could factor by grouping, but remember, the factoring is the reducing step, right? Factor and cancel. Before you reduce, you simplify. Are there any like terms, AC, negative BC, positive AB, negative AC, that can combine? Right, the AC and negative AC actually will just cancel. So that actually simplifies our life, doesn't it? Because now we're just looking for a common factor in those two terms. Well, technically it wouldn't, well, okay, and then if you pull out a negative B, there's a couple ways you can go here. You pull out the negative B, that changes to a C and a negative A. Or, if you pull out just the B, it still leaves you with a negative C and a positive A. But if you put the negative C and the positive A this way, now you don't have to worry about the negative. And that's kind of what I showed here. One method is to flip-flop them, so the positive one's first. then it's just a straight factor out B cancel B. Or you don't flip-flop them, you pull out that negative, which slides out to the front, and then the B, and so forth. Go and work on 1924, let you see. What do we have to do with these denominators, class? Factor or group them. In this case, both of them. Factor. Make sure you got this initial step. Once you finish 19, check your work. Once you finish 19, check your work. This problem has everything. Factored denominators. Getting that common denominator under the big long line. Really couldn't combine, but by simplify, it meant get it in descending order to set up factoring and canceling. I'm not sure what you did on 19.
You totally messed up.
Okay, so look up from your paper, stop writing for a moment, look at the board. You didn't factor your denominators. You've got to factor polynomials, right? Right off the bat, get them factored up. That way you can see what pieces do I put in here. Well, that needs to be in there. That's a winner. It's a tie, just put one of them in there. That's a winner. Okay, what changed? Well, that didn't. Oh, look at that, that's changed. So you put it in. Well, this isn't there. That's already there, that's already there. Well, now, this part, pretty easy. The hard part, quote unquote, comes in remembering to put it in descending order, seeing how to factor it. Hey, a factor cancels away and going from there. To what? Well, they're working. Brecken, help me on this next one. So, I don't really care about numerators so much, but denominators. I need to factor this here. to check the outer inner before we move on. Okay, good. Just want to make sure. Okay, so, and this doesn't factor, so I should group it. All right, so I draw my long line. What do I put under it? Well, there is a clear winner here. This one has two of them. This one only has one of them. Just like an a squared and an a, you would say the a squared wins, right? Well, this is x plus 3 squared in a sense, right? There's two of them. This only has one. This one wins. So the winner goes down here. Does that make sense? All right? So, what changed? So what changes? What do I write down? All right? From here to here, what changed? There's another x plus 3 that the winner had that it didn't have, right? So, top and bottom there to get. Now what? To get?
2x squared.
All over the x plus 3. Now normally, a lot of times we'd be done. But I should check and see, can I factor that? I don't really know. It's not though like I've got a 17 or something like that. I can't do anything with a 17. A 15, there's some stuff I can do. Let's try it. If it doesn't factor, we're fine, right? So the 2x squared signs 15. What's the most natural way to split up a 15? 5 times 3. Let's give it a try. Let's see what happens. Outer, inner, 6x, 5x. Yeah, it does factor. Now, does it help me that it factors? Yes, because it does allow something to cancel now, doesn't it? Now, I canceled away x plus 3, but since I already have one here, I don't have to write anything. That said, it wouldn't be wrong to say x can't be negative 3. But there's my answer. 2x plus 5 over x plus 3. How many got that for number 24? Right, did you factor it down and reduce it at the end? Now, there is something we could have done to make our life easier. If you saw it. If you saw that this could have factored into x plus 5x plus 3. Because then I could have reduced up front. And then I would have already had a common denominator. So when I draw my long line, it's a tie. They each only have one x plus 3, so a single x plus 3 is the denominator. The numerators are x plus 5 plus x, or in other words, 2x plus 5. So reducing up front might have made the work maybe a little bit easier. Not a whole lot different, though, either way. So I mean, I'm not saying there's a huge advantage there. Questions on 19 and 24. If it looks like you can reduce, give it a shot. Okay? Sometimes you look at it like, I know that ain't gonna factor, but check and see if it looks like it's close. Write this one down if you would at your seats. 2 over x plus 3 minus 5 over 3 negative x plus x squared over x squared negative 9. 2 over x plus 3 minus 5 over x3 negative x plus x squared over x squared negative 9. What's the thing I've got to do anytime I see polynomial denominators, class? Either or, factor or group. Look at the first denominator. What do? Group it. Look long and hard at that second denominator. What do I do? Out a negative. There's nothing that really factors out other than that negative. But if I factor out the negative, what does it give me? A negative 3 and a positive x, right? Or in other words, an x and a negative 3. Does that make sense? Questions on factoring out the negative. However, think about this for a minute. The fraction is negative. The denominator is negative. How many negatives do I have in my fraction class? What's the rule with 2 negatives? If there had not been a negative there, this negative would have moved out front. Make sense? Look at the last thing. What do I need to do with that?
Factor.
Into, which is, so, draw A. What do I put under the big, long line? Maddie? Do I need to change anything about the first fraction? Noah? What do I do?
Multiply x negative 3.
Good. Multiply x negative 3 by top and bottom. Technically, the bottom's already been done, but the top would give me what numerator?
2x negative 6.
All right. What about the second fraction, Gavin?
X positive 3.
And again, we canceled two negatives to give us a positive, so we don't have to worry about a negative 5 being distributed anymore.
X positive 5. 5x positive 15.
There we go, 5x positive 15 as we distribute the 5. What about the last fraction? Reckon? Stays the same, so just bring down the x squared. In the numerator, what will it simplify to, Maddie? I'm sorry? X squared positive 7x positive 9. Is that going to factor? No, the 9's got to do it by itself. There's no help coming here from the 1, right? 9 and 1, 3 and 3. Nope, not going to factor. So we don't have to factor and cancel this time. But check it, right? See if you could factor. Write this one down as well if you would. 2a negative b positive a squared over a negative b. We looked at an example problem yesterday in your textbook, but haven't worked a problem like this where it's not necessarily fractions plural that you're adding together. There's only one fraction. The rest of it isn't a fraction. But you want to make it a fraction by putting it over 1. Now there's two ways you can do this. Method number 1 is to put the whole thing over 1 collectively. You draw your big long line. Your LCD obviously, class, is, it's the only thing down there. It's got to be the common denominator, right? And then you multiply here, top and bottom, by a negative b. How do I multiply the two binomials together, class? FOIL. That's option number 1. Option number 2 actually breaks it into more steps, but they are easier steps, if that makes sense. Treat each thing like it's over 1. Do you see that? Treat each thing like it's over 1. Still draw your big long line. Your LCD is still going to be, but now instead of thinking of FOIL, you're just going to do two different distributions. Now technically FOIL is a double distribution anyway. But this way, instead of FOIL, if you're weak on FOIL, each distribution can be handled separately. How many say, I actually like separate distributions instead of having to do FOIL? How many say, I'd rather just do the one step and just FOIL and cover it that way? All right, it's your choice. You work it however you want to. Since 3 out of 4 of you chose the method that's currently on the board, I'm going to leave it up, but the answer will be the same either way. Did you get it, Gavin? What'd you get? The real key is right here. Getting the negative times negative gives you that positive. Just got to be careful with that step. Maddie checking work. Got it, good. Reckon's finishing up. Any questions on this one? Let me give you two more to do on your own. Reckon finished? Oh, here's the problem. So right here, your outer should have been a -2 maybe. Right? Positive times negative. And the inner, you've got the negative AB. Should have given you -3 AB. Instead, you cancel your positive AB. But other than that, and then I don't know that it would have factored even with what you had. You were just checking to see. Okay. Does that make sense? Fine. We're going to work these two. this problem was a lot harder than it was supposed to be. I'm sorry. This was supposed to be a negative. Yeah, so your LCD technically should have been x negative 3, x positive 3, x positive 2, which is just ghastly, isn't it? I'm sorry. Yes, sir?
Why did you bring down the negative?
Well, the negative would technically float out here to be associated later with adding the inverse to the 12. Because otherwise, Gavin, you've got to put the negative over here. Now, you could do either one, but if you bring the negative here, now you've got to apply it up here as well. So it's either place. It ends up working out the same. But yeah, it wasn't supposed to be quite so bad. Let me just work what you had to work, though. And then here we had the x, and the x negative 3 gets the x. Yeah. Did anyone get that answer? Excuse me. Yeah. Anyone get that answer?
No. It might have if I had anything confused with that negative.
Does the negative make sense now? Let's do this. Move on to the next problem. Let me have us redo this problem the way it was intended, or similar. We'll change it slightly to capture the negative in a different way. Yeah, it was not supposed to be that hard. Should help if I could read. Next problem was much easier. Questions on the second one? With all the x's and y's? How many got the second one correct? Good. Then working the first one, I still forgot to change that little detail. There we go. Now, reworking the first one the way, similar to the way it was originally supposed to be written up. Got it now? Good. How many so far so good on the last one? All right. So we need to add the inverse so that as we multiply by an x, it's a negative 7x squared. I kind of feel like I need to put it in descending order though, because it might factor. So I'm going to put the negative 7x squared, positive 12x, negative 24, but we're going to need to do what with this negative? Yeah, bring it out front as we factor it out to leave ourselves with this. And now the question, can we factor? Has to be 7x and 1x. Signs are going to have to both be negative. I don't think it could. I don't think there's any way it can, because anything I put with that 7 is going to make it huge, and I have to put something with the 7. So, nope, I think we're off the hook. I think there's our answer. Is this what you had, Maddie? It is not. Question? All right, no, is this what you had? You did get it. Gavin?
No, because my brain put that negative in the wrong spot, so I was getting a very huge answer.
Okay. All right, homework for this evening, and I'm going to give you homework tonight because you needed to get ready for the test, but the next 2 nights I'm not giving you any homework, okay? So homework for this evening is to do page 433, numbers 16, 18, 20, 22, 27, and 33. So 6 problems for homework tonight that we'll look at tomorrow as we review for your test Friday. Again, there will be no homework tomorrow. It'll just be ready for the test. There will be no homework Friday after the test. There is a help class tomorrow. I understand fractions can present a challenge, so if you need some additional help, come to help class after school tomorrow, about 3:05, 3:10-ish to about 4 o'clock, and then of course test Friday. All right, you are dismissed. Have a wonderful rest of your day.